Hello, I'm Meral Büyükurt. I think by now we know each other a bit, but let me introduce myself for this video as well. I'm a professor of business technology management at John Molson School of Business, and I have been teaching the information systems analysis course for quite a few years. This is the second of two videos that covers pieces analysis. As I mentioned in the first video, in the past, a good understanding of pieces analysis resulted in outstanding improvements in students' projects. We expect this to be true for you and your team as well. By previous project phases, I mean the phases we covered in the first video on pieces analysis, which are the first three project phases, right? So we will start from where we left off at the end of phase 3 of the project. I'm assuming you are quite familiar with this graphic summary of project phases, and you have been referring to it frequently through the semester. Since repetition typically leads to retention in memory, I thought it would be useful if I included it in this video as well. Before you move on to phase 4 pieces analysis tasks, you need to complete pieces analysis table in phase 3. In other words, there are 3 things you have to do. 1, identify the user requirements, owner's directives, and opportunities for improvements, and incorporate them into the initial problems list. 2, identify the underlying problems. And 3, map the underlying problems to the initial problems. This is what you have completed at the end of phase 3. When you know what the problems are and where they are, you will be ready to start working on the solutions you are going to propose in phase 4 of the project. The answer to what problems are you going to propose solutions for is the underlying problems. You coded them and described them in the second table. The process and the data store numbers associated with each underlying problem in the first table is where the problems are. So you're ready to start phase 4 if you have completed these 2 tables. We realized the need for creating a method to support the students as they approached the end of the project. We could see that they were stressed out. After weeks of collecting data, narrating and modeling what they learned, and understanding the problems, opportunities, and directives in their client's current system, teams frequently found it overwhelmingly challenging to summarize their findings and recommend solutions to the problems they identified. They needed a structure that would ease them into this task. They needed help to maintain their focus strictly on the process model that they had developed. They needed help to demonstrate how their proposed solutions corresponded to the process model of the current system. What they needed was the last step in pieces analysis methodology. Looking at the project's phase 4 graphic, there seems to be one task with two parts, but neither can be accomplished before pieces analysis is completed. So there are actually three tasks. One, developing the solutions for the problems you identified. Two, developing the DFD of the proposed system. And three, developing the narrative of the proposed system, but just the parts about the changes you make. The objective of this last pieces analysis task is to enable the teams to develop solutions that can be traced back to the problems they identified. This supports you in your accountability to your clients. Remember that you promised you would identify problems and recommend solutions to them. This also supports you in remaining within the requirements of the course. You use the process model to represent what you learned about your client system, so you need to represent your solutions in the same process model as well. Additionally, this supports you in avoiding the shortcut some of the previous teams used when they recommended a software solution before taking BTM 496, where you will learn about how that is done. How long is this phase? About 1 to 2 weeks. Once you decide on the solution, making the changes in the DFT and the narrative does not really take much time. Pieces analysis tables you completed in the previous phases were all organized by the problems you encountered initially. By now, you have identified all the underlying problems for the entire system, in other words, all the subsystems. You will now find solutions to each underlying problem in each of the subsystems. So it makes sense to organize the template by the underlying problems, hence the first column. It is necessary for the underlying problem codes to be consistent across all subsystems. For example, the underlying problem code A in subsystem 1 should be identical to that in subsystem 2. For the second column, you need to refer to the pieces analysis table you completed in phase 3. You extract all the process and the data store numbers associated with each underlying problem in each subsystem, and you enter them in the second column of the current template. In the third column, you identify the changes you're proposing to the processes and the data stores by color coding them. You may use your own color coding scheme as long as you define them, just like we did. You then need to verify the correspondence of columns 2 and 3 to ensure that all initial problems you identified in column 2 are addressed in proposed changes column, the last one. You have now completed pieces analysis. All you must do next is to incorporate the changes you're proposing into the DFD and the narrative of the proposed system. These are a sample of challenges our former students frequently experienced as they were moving from the problems in the current system to the solutions in the proposed system. Before moving on to pieces task in phase 4, it is a good idea to review the underlying problems you identified, to verify that they are 1, short, simple, and specific, and 2, consistent across all the subsystems. Notice that when a process is not standardized or not consistently used, it is a good idea to ask your client about their reasons, commitment to them, and intentions for future use. Clients' responses may guide you in the solution you suggest. The same is true for data storage. Quite frequently, teams observe that their clients are challenged in the way they store data. For example, where they store it or how many different places they store it in. Once again, it's a good idea to ask your client about the reasons, the commitment, and the intentions for future use. Clients' responses may guide you in the solutions you suggest. This example is based on a project done during the pandemic when many small businesses were struggling with the challenge of moving their businesses online. Most of the clients the teams had during this time were from the pool of such businesses. At this point, I suggest you stop the video and read the case narrative that is posted on Moodle Week 9, and then you can proceed with the video. I'm assuming that you are now familiar with the case narrative. The list of all the process and data store numbers and labels are here just for your convenience. You might want to refer to it as you go through the solution. Now note a couple of things. One, while only the first subsystem is included in the example, the numbering of the processes was not changed to demonstrate how each subsystem would be represented if there were 2 or more subsystems. 2, normally, all data stores are numbered sequentially in a subsystem, except for those that are shared, right? But I kept D10 as it was in the original case. There is no other reason for it not to be numbered sequentially. Consider it random. Let's start with the table 1. Notice that all process and data stores associated with an initial problem are listed in the first column. In the second column, notice that the initial problems are listed very specifically so that they can be associated with the process and the data stores. A reminder once again that mapping the initial problems to pieces categories is just for assessing their impact on the system. These are just suggestions. Yours might be different. Notice also that in the last column, some initial problems may be associated with a single underlying problem, whereas others with 2, 3, or more. That's okay. Now let's have a look at the second table. Let's go by each underlying problem. In A, where data is stored in memory, well, first of all, data is not safe, secure, not accurate, not accessible by all users. That indicates there's serious problems with storage in memory, doesn't it? But still, D10 and D2 exist in the current system DFT because they refer to their memory for order selection criteria and painting attributes. But it is highly likely that these data stores lack integrity. In other words, their logical content is highly likely not consistent, since some fields may not be recorded in memory or always retained, or no data may be captured at all. Memory is also not a safe and secure data storage medium, since stored data may be randomly lost. You forget it. As a result, data stored in memory may not be accurate due to errors in data capture or loss later. Additionally, data stored in memory is not accessible by all users who need it. Only one person has access to it. About the underlying problem B, where data is stored, that is, stored data is not safe or easily searchable. In addition to memory and notebook, desk or cell phones are also examples of data stores that are not safe or easily searchable. In this case, D1, D2, D3, and D10 are examples of problem B, having problem B. About the underlying problem C, where data is not captured or tracked, well, sometimes prices are not recorded in D4. And also, termination of an order is never recorded in D1. Finally, about underlying problem D, where a process is not standardized. Well, when a process is not standardized, it might be missing or may not be consistently used. It's there though. Process 1.1 never records termination status of an order in D1. Process 1.5 does not always update D4, which has an impact on D4. Since we are analyzing only one of the subsystems in KK Canvas's case, there is only P1.0, the first subsystem. But you know that you can include as many subsystems as you have in the system that you're analyzing. Now, most of the proposed changes in the last column are easy to understand, but I would like to go over one that might be a bit more challenging, which is the process 1.6 and 1.9. To find a solution for problem D, process 1.6 is deleted and replaced by process 1.9, which, in addition to what process 1.6 already did, it also captures and records the termination status of the order in D1. The color coding in the last column indicates these two changes. This summary is included for clarity purposes only. It is not required for the project report. This is the final verification of the proposed changes. First, present the changes you're proposing to your client and receive their feedback. Start with communicating to them that you base the proposed changes on the problems and opportunities you identified, users' requirements, owners' directives, and taking into consideration functional and non-functional requirements. Second, document the client's reaction and feedback to the proposed changes. Well, the final decision is the team's, but make sure that you justify any deviations from the client's preferences. And finally, revise the DFT and the narrative according to the proposed changes. Phase 4 pieces table is your guide, and it will not take much time. Well, thank you for watching the video. We do appreciate your feedback on this video. Please communicate that to your instructor.